Hello, my name is Emma Baumgartner, and I will be discussing a topic that highlights engineering applications of mechanical vibrations. This topic is smart materials in vibration application. Throughout my engineering courses, I have developed a fascination with the way materials are used in certain applications, which really drew me to pursue this topic. Before I get into the topic of smart materials in vibration applications, a brief background in vibrations will be helpful. Vibrations can be defined as the study of the repetitive motion of objects relative to a stationary frame of reference. Vibratory systems must have a component that stores potential energy as well as releasing the energy as kinetic. Certain elements contribute and affect vibration responses and can be controlled in certain applications. High-frequency vibrations tend to be avoided since it is a source of noise. Noise is attributed to dynamic instability. Some examples of vibrations are a grandfather clock and a guitar. If you have ever seen a grandfather clock in a house or on a building, you are aware that there is a pendulum in the clock that moves back and forth. This repetitive motion of the pendulum is pulled by some force, either by physically pulling it or a mechanical force acting upon it. The pendulum begins to oscillate when released. The pendulum will move a certain distance, and when it returns to its original position, it will travel almost the same exact distance in the opposite direction. The pendulum will eventually lose enough energy and will stop if there is no additional forces acting upon it. The repetitive motion of the pendulum is oscillatory, and this can be defined as simple harmonic motion. The other example would be an instrument such as a guitar. If a guitar is struck, the vibrations of the strings produce a sound which is heard as music. Similar to the grandfather clock, when the guitar is struck, the strings move a certain distance, and when it returns to its original position, it will travel almost the same exact distance in the opposite direction. The energy in the vibration of the strings is dissipated in the form of sound. The sound of the guitar string eventually dies out, and there is no sound to be heard. This represents the amplitude of the vibration gradually decreasing. As I mentioned previously, high-frequency vibrations are avoided due to the noise that is produced. Certain vibration applications, such as a car driving down a bumpy road, will produce large frequency, resulting in a lot of noise. A car is just one example on how smart materials are integrated in the vehicle in order to reduce sound. In a paper by Doppenberg, Birkhoff, and Overbeek, they introduced two methods to control acoustics. One method being structurally, and the other using vibroacoustics. An active structural acoustic control system is a system in which transducers are integrated in the material. Transducers are something that converts energy from one form to another. This system reduces sound radiated by the structure, such as the roof of a car. In order to reduce sound, the authors suggest an acoustic approach, which involves placing a thin layer of acoustic actuators in front of a radiating wall. The sound is therefore neutralized by the layer. The other approach is vibroacoustic approach. This approach is when actuators are fixed to the material of the wall. The actuators are placed to modify the vibration pattern so that the wall does not radiate the sound. Commonly used materials for transducers are based on piezoelectric ceramic materials integrated in composite materials. The authors also suggest an active isolation control system. This system focuses on the source causing the vibration and the noise radiation of plates and panels. Examples of the actual source include machine or engines. It is more efficient to reduce the vibration in the transmission path rather than reducing radiation in the panel. Actuators are very critical in order to reduce sound near the source. Actuators must be compact and efficient and have high longevity in order to generate high dynamic forces. The previous examples I described has to do with internal vibrations rather than external. Throughout this course, there are many concepts that I learned in solving problems relating to vibration noise. Problems mostly include a mass and spring system that oscillates back and forth, but there are problems that also include a car driving on a bumpy road. The car's wheels in contact with the bumpy road is an example of an external vibration of a car that a car will experience. This example illustrates harmonic excitations. Harmonic excitations were discussed on how they are a common source of external force applied to machines. This class has enlightened me on the everyday applications of vibrations while also teaching me how to solve vibration problems.